This is a Pocket FM radio that I made. It's convenient to use and the quality is relatively good. I'm going to be explaining how it works and how to make one. Now, there are a lot of videos out there that conceptually explain how FM radios work, and there are a lot of videos of FM radios people have made using this specific chip, the TEA5767. In this video, I'm going to try to tie these together and explain how to use the TEA5767 with any microcontroller or microprocessor to make a quality FM radio. First, we need to ask what exactly is the function of a radio, specifically a receiver, not a transmitter. Well, at any given time, there are thousands of different radio waves in the air, each with a different frequency, ranging from kilohertz for AM radio all the way to 5 gigahertz for Wi-Fi. An antenna can and does pick up all of these waves. So the first function of a radio receiver is to narrow down what is picked up by the antenna to the frequency we want. First, we narrow down to the FM range, ignoring signals of all other frequencies, then to the specific channel frequency we want to listen to. Keep in mind, these are the frequencies of the carrier waves because radio waves are modulated. So the next function of a radio receiver is to extract the sound wave from the radio wave and amplify it so that all we hear is the actual audio and none of that radio distortion. Again, this video is not meant to be a detailed explanation of the concept of FM. Check out the videos in the description if you want to be familiar with that first. Now let's take a look at the block diagram for this chip. There are a lot of different parts and it looks pretty complicated, but a lot of this stuff is simply there to improve the quality. The fundamental parts are the same as any other FM radio. As you can see, there's an FM tuner, a mixer and a PLL, an IF filter and amplifier, a limiter, and an FM demodulator. Each of these have a specific function, and going in depth will take a lot of time, so down in the description I've attached the best videos I could find that thoroughly explain these parts. Essentially though, this chip takes the input from the antenna, narrows down to a specific FM channel, demodulates the radio wave, and outputs the audio wave. Now, how to use it with an MCU or MPU. If you've done a little research on this chip, you might have found that there's an Arduino library for it, and a lot of code that makes it compatible with Arduino. However, there's little out there on how to use this chip with any other microcontroller using assembly code rather than C. So I'll explain how to communicate with this chip using the I2C bus on it. Keep in mind this is the I2C protocol, so normally both lines are pulled high. As usual, the transfer starts with a start condition, defined on page 12 of the datasheet. This is when the slave data line goes low, followed by the slave clock line going low. Next, we send the address and the read-write bit. The address for this chip is 1100,000, also on the datasheet, and reading won't be necessary for the basic function of selecting a channel, so the read-write bit will be a 0, indicating a write. Of course, next comes an acknowledge bit from the chip, which occupies 1 clock pulse. This is all standard I2C protocol. If you're not familiar with it, I recommend watching the video in the description that explains it in detail. Next up is a transfer of 5 bytes of data which configure the channel and other settings of the chip. The first byte will be a 0 for the mute bit because we don't want the radio muted, a 0 for the search bit, and the upper 6 bits for the PLL. The next byte is the lower 8 bits for the PLL. These first 2 bytes are where we select the channel, specifically the 14 bits for the PLL. Here's the formula to figure out what to put in these bytes, depending on the channel you want. You need to first plug the channel frequency into the formula, which will be in Hertz, round the result to the nearest decimal number, convert it into binary, and split the upper 6 and lower 8 bits. For example, if I wanted to listen to channel 88.3, I would plug in 88,300,000 for channel frequency, and using a calculator I get 10,806.2441, which I round to 10,806. Then I convert this to binary using an online converter and get 10101000110110. Therefore, the upper 6 bits for the PLL are 101010, and the lower 8 bits are 00110110. So the first data byte I sent to the TEA5767 chip would be 00101010, and the second byte would be 00110110. And this will tune the channel to 88.3. But we're not done just yet. Remember, there are 5 bytes in the transfer, so there are 3 left to go. However, these are just control bytes to configure certain settings of the chip. If you want to read about each bit for the 3 control bytes, check out the pages 14, 15, and 16 of the datasheet, which I attached below, but here are the default values. Byte 3 is 10110000, byte 4 is 00010000, and byte 5 is just 0. Just to review, here are all 5 bytes of the data transfer we would use to set the channel to 88.3. Once you send all 5 bytes, there will be another acknowledge bit from the chip. After this, you need to set the slave clock line high and then the slave data line high. This is the stop condition, meaning that the transfer has ended. And with that, you can set the channel. That's the guide to using the TEA5767. The schematic for my specific radio is down below. I used the PIC12F683 as the microcontroller to communicate with the receiver chip, and the LM386 audio amplifier to make the output audio from the receiver strong enough to pass through a 3-watt speaker. I added one of these 128 by 64 blue and yellow OLED screens, which is controlled by the same I2C bus, to display the channel frequency. Just like the TEA5767 chip, there's little documentation on using the screen without an Arduino, even though it's very common. So let me know in the comments if you would like for me to make a video on how they work and how to use them. What you want to use as an antenna is up to you. One of these simple jumper wires will work well because the quality really depends on your location and which channels are broadcast closer to you. However, using an extendable antenna like this one will make a difference for weaker channels and give you a stronger connection and cleaner audio overall. This circuit uses a 5-volt power supply, so if you're using a 9-volt battery like I am, you'll need a 5-volt regulator. I'm using the LM7805. Also, the TEA5767 chip operates on 3.3 volts, so you'll need a regulator for that too. I'm using the LD33V. Again, the entire schematic is attached below. You can design your own case if you'd like, but the case for my radio is in the description as an STL file. The assembly is always the most annoying part for me because I always forget to account for the space the wires end up taking, but I was able to put it together eventually, and here is the finished product.
Of 100 magazine pages, made people smile. Everywhere that I went, I even put it on the first night president. It's a lot of bad things that they wish and they wish and they wish and they wish and they wish on me. Yeah.
I know I didn't go deep into how FM works and the individual parts of a receiver, so if you have any unanswered questions, feel free to ask them in the comments.